Assalamu alaikum. My name is Amna Irfan. I'm from the Department of BS Biotechnology. Today I will tell you about Avogadro's number and mole. First of all, I will talk about Avogadro's number. What is Avogadro's number? Avogadro's number is the amount of particle which is present in 1 mole of a substance. It is denoted by Na, and its value is 6.02 into 10 to the raised power 23. Now I will explain the concept of Avogadro's number. In chemistry, we deal with very large amount of masses which contains many atoms, formula units and molecules. So concept of Avogadro's number facilitate us to count these particles. As we know, it is very impossible for a chemist to count these particles. So we can say that Avogadro's number, which is 6.02 into 10 to the raised power 23, number of particles, that is atom, formula units and molecules, is equal to 1 mole, as 12 eggs are equal to 1 dozen. Now I will tell you the relationship between mole and Avogadro's number. Now I will tell you the relationship between mole and Avogadro's number. Examples include 6.02 into 10 to the raised power 23 atoms of carbon is equal to 1 mole of carbon. Similarly, 6.02 into 10 to the raised power 23 atoms of H2O is equal to 1 mole of water. H2O is actually a molecule. And then we'll have the third example of formula unit. 6.02 into 10 to the raised power 23 formula unit of NaCl, sodium chloride, is equal to 1 mole of sodium chloride. Thus, 6.02 into 10 to the raised power 23 atoms of elements, or 6.02 into 10 to the raised power 23 molecules of molecular compound, or 6.02 into 10 to the raised power 23 formula units of ionic compounds are equivalent to 1 mole. For further explanation about number of atoms in molecular compound or number of ions in ionic compounds, I will tell you at least 2 examples of it. If we talk about one molecule of water, so it is made up of 2 atoms of hydrogen and 1 atom of oxygen. Hence, 2 into 6.02 into 10 to the raised power 23 atoms of hydrogen and 6.02 into 10 to the raised power 23 atoms of oxygen constitute 1 mole of water. Then we'll have the example of formula unit of sodium chloride, which is consists of 1 sodium and 1 chloride ion. So there are 6.02 into 10 to the raised power 23 number of sodium and 6.02 into 10 to the raised power 23 chloride ion in 1 mole of sodium chloride. Thus, the total number of ions in 1 mole of sodium chloride is equal to 12.04 into 10 to the raised power 23, or 1.204 into 10 to the raised power 24 formula units. Now I will tell you the concept of mole. So what is mole? A mole is a substance that contains 6.02 into 10 to the raised power 23 number of particles. It is denoted by MOL. It establishes a link between mass of a substance and number of particles present in that mass. So when we talk about substance which may be in the form of element or a compound which is present in molecule or ionic compound, we can have masses in atomic mass, form, molecular mass or formula mass. So we can measure all these 3 masses in the form of atomic mass unit, which is denoted by AMU. When these particles are expressed in grams, they are known as molar mass. The scientists have agreed that Avogadro's number of particles are present in 1 molar mass of a substance. Then I will talk about the quantitative definition of mole. The atomic mass, molecular mass, and formula mass expressed in grams is known as molar mass. And all these three are equal to 1 mole, which is denoted by MOL. Now I will give you some examples of mole. First of all, I will tell you that 12 gram of carbon, which is present in atomic mass, is equal to 1 mole of carbon. Similarly, if we talk about molecular mass of H2O, which is expressed as 18 gram, is equal to 1 mole of water. Then we'll have molecular mass of H2SO4 expressed as 98 gram, is equal to 1 mole of H2SO4. Then we'll have formula mass of NaCl, sodium chloride, expressed as 58.5 gram, is also equal to 1 mole of sodium chloride. Then we'll talk about relationship between mole and mass. Number of moles is equal to given number of particles divided by Avogadro's number. Similarly, we can also write it as given number of particles over 6.02 into 10 to the raised power 23, or we can also write it as number of particles. If we concerned with the number of particles, so we can write it as number of moles into Avogadro's number. So this is the relationship between mole and number of particles. The main relationship between mole and mass is number of moles is equal to known mass of a substance divided by molar mass of that substance. Or we can also write it as mass of substance which is present in grams is equal to number of moles into molar mass. So the whole result of this talk is that Avogadro's number is very related to mole. So if we can say that if a substance which is equal to 1 mole, so the number of particles present in it is equal to Avogadro's number. That's all from my side. Thank you.